topic. Okay. So today we are going to discuss the new chapter, means the new part, we can say LTI system, linear time invariant system. Okay, write the topic. Linear time invariant system. Invariant system. Okay, linear LTI system means LTI, linear time invariant system. So any idea about the LTI system? What is LTI system? So first of all, write it down. A very good concept. This is very important. Transfer function will always be calculated for LTI system. In college, no one will teach you this thing. Transfer function only calculate for LTI system. Okay. So what is the meaning of a LTI? Linear and time invariant. I taught you both things. What is the meaning of a linear and what is the meaning of a time invariant? Okay. Now you have LTI system. LTI system. So if my signal is coming, x of t signal is coming, and you are getting the output y of t. Okay. So h of omega, or you can write h of s, is equals to what? Transfer function. Transfer function. So transfer function of system. Okay. Or you can write like this: h of t is equals to impulse response of system. Impulse response of system. So both are means we are applying the inverse Laplace transform to get this result. Inverse Laplace transform to get this result. Okay, there are a different way to define input and output relation of a LTI system. Write it down. There are different ways to define input and output relation of LTI system. Okay, so what is the by providing, and you know that impulse response means delta t. Okay, so how can we say? First is by providing impulse response, okay, of system. And the second way is by providing differential equation of the system. Differential equation of system. Okay, and block diagram representation of the system. Second way is by providing block diagram representation. Okay, so by providing block diagram representation, and you can write the second method. Second method is nothing but y of t can be written as x of t convoluted with h of t, and you can write it like this: y of s is equals to x of s into h of s. Okay, guys, I hope you remember h of s is your transfer function. Transfer function means output upon input. Laplace transform. So output Laplace transform divided by input. Okay, so you need to get the output. So what you will do? H of s into x of s, right? So this is multiplied. But if you want to get into the time domain, so y of t multiplication will become convolution. H of t convoluted with x of t, right? So LTI transfer functions means the transfer function is defined for only LTI system. So h of s is equals to y of s by x of s. You want to get the output. So output is y of s is equals to h of s into x of s. And you want to get into the time domain, so you can directly convolute it. Okay, you can directly convolute it. Okay, or either you can what you can do, h of s, find the transfer function of x of s, means Laplace transform of x of s, and multiplied it and get the Laplace inverse. You will get your result. Okay, so transfer function is a very easy tool. Transfer function is a very easy tool. Transfer function of system helps in the output calculation. Output calculation when output is calculated by frequency domain approach. What is the meaning of S? S is nothing but j omega. Impulse response of the system helps in the output calculations. Impulse response, or we can write it impulse. You will understand these things by doing problem, and I will teach you, don't worry. Impulse response of system helps in the output calculation. Okay, when output is calculated by time domain approach. When output is calculated by time domain approach. Which is easier? This one is very easier. Okay, we have a two way to do these things. Now, what is the meaning of a transfer functions? What is transfer function? Transfer function of system. What is the meaning of a transfer function of the system? It is the ratio of, write it down, it is the ratio of Laplace transform of output to Laplace transform of input when all initial conditions of system are 0. Okay, What is this? H of s is equals to Laplace transform of y of s divided by Laplace transform of x of s. This is the meaning of Laplace transform. So here zero initial condition. Zero initial condition means v of 0 minus, I of 0 minus, whatever we are doing with a capacitor, inductor in network, all are 0. So we are assuming the circuit initial part was 0. Initial condition. Okay. You need to note down a very important point. For a linear system, output should be 0 for a 0 input. Okay. If you have for a linear system, output should, this kind of a question asked in ESE examination. Okay, directly they will give you the statement. So for a linear system, output should be 0 for 0 input. Okay. Now what is the meaning of a 0 input response? ZIR. So I told you that I will teach you these things in network. I told you that I will teach you in signal system. What is the meaning of a 0 ZIR? ZIR. Okay. So write it down. The ZIR means 0 input response. Okay. So what is the meaning of a 0 response? It is the output of system due to non-zero initial condition. Initial condition of system. When system input is 0. When you are providing no input, means 0 input, but because of the initial conditions you are getting the output. So that is the meaning of 0 input response. When system input is 0. So this is the meaning of 0 input response, ZIR. It is also known as natural response. Write it down. It is also known as natural response. Okay. Natural response of system. Yeah. What do you mean by ZSR? So for AC transient, I hope you guys remember AC transient, we are using the two concepts, ZIR and ZSR. So ZIR means your input is 0. Okay, you are providing input, your input is 0, but due to the further means previous initial condition, you are getting the output. So because of the initial conditions, whatever the output you are getting, when you are making the input 0, the meaning of ZIR, that is the meaning of ZIR. And what about the ZSR? ZSR, zero state response. So in this what you do, ZSR, so zero state response. So it is the output of the system due to the applied input. It is the output of the system due to the applied input when initial conditions are 0. When initial condition are 0. It is also known as a forced response of the system. Write it down. So here what you are doing, you are making your initial condition 0, you are directly calculating initial condition. Always remember, means what is the meaning of an initial condition? Plus minus. So VC 0 minus, if suppose 2. So we are making the circuit like this. Okay. So battery is coming, means then capacitor is coming. So we are making the plus minus voltage. We had seen in a network. So this type of VC 0 minus, we need to make it as a 0 for finding the ZSR. We will simply take one capacitor, one inductor, this value is this value is this, and solve the circuit. Will not take this, will not consider these things. Okay, but and we will consider the input, what the input we are applying. Okay, but for zero input response, we will make this as a zero and we'll consider this initial conditions. So this is the meaning of a ZSR and ZIR. So it is the output of the system due to the applied input only when initial conditions are zero. And it is also known as, it is also known as forced response. Forced response of system. Forced response of system. Okay. So what do you mean by total response? Total response means ZIR plus ZSR. Total response is nothing but ZIR plus ZSR. So ZIR is your natural response, ZSR is your forced response. You are making your input here, and here your input is 0 you are making, but you are taking the initial condition. You are not taking the initial condition in this. So ZIR is due to initial condition and due to the applied input ZSR. Okay. So definition of a transfer function includes zero initial condition. So for transfer function, zero initial condition means your ZIR value will be 0. Okay, because we don't have to take the input response, means initial response. So definition of transfer function, what we can say, includes zero initial condition for linearity property of system, because non-zero initial condition makes the system non-linear, because non-zero initial condition makes the system non-linear, Whenever you will have a zero initial condition, your system will be non-linear. So that's why, and non-linear cannot be your LTI system. And for LTI system, that is the condition that you will get linear. So linear, and for linear there will be a no initial condition. Okay, and if there will be the initial conditions, you will not get the transfer function. Okay, you will get non-linear function. Okay. So write down the next topic, then we'll go for the numericals. Then you will understand in a better way. Yeah. Impulse response of the system. Impulse response of system. So what is the impulse response of the system? X of t, this is your LTI system, this value you are getting y of t. Okay, you are taking x of t as an impulse response, means your input is delta of t. And what is the meaning of a delta of t? At zero value you are getting infinite magnitude, but area is 1. So always remember, impulse function will have a infinite. This question has been asked several times, and people are doing mistakes in this. They are making the magnitude of the impulse response, they are putting 1, but this one denotes the area. Okay, impulse I already taught you in the previous class. This is minus e by 2, this is e by 2, and this is 1 by e. Okay, where e value is 0. Okay, if you will find the area, you will get 1 by e into e. That area is 1, but when you substitute e as a 0, it will come infinite. So magnitude is infinite. Okay, so this will diminize like this, and it will give you, the figure will be like this only. Okay, and where you are getting the value? At 0 only. What value you are getting? Infinite value. What is the area? 1. I hope you recall these things. Yeah. So this is the LTI system. Y of t is equals to, means you are making you are giving the impulse as a delta t, and you are getting y of t. Okay. So if you want, means if your input is delta t, what you will get? Y of t is your, see what I am telling, h of s is equals to y of s into x of s. Alright, h of s is equals to y of s into x of s. But if you want to write in the form of time domain, so h of t will be equal to y of t into x of t. Correct? Convolution will come. So multiplication will become convolution. And if you are making your input as a delta t, you are forcefully giving the delta t. So h of t will be y of t convoluted with delta t. And I told you the property of this. This will give you the result. Means y of t convolution with delta t will give you y of t only. So you will get y of t only. So h of t is coming as y of t. So that is the known as impulse response. So impulse response means whenever you are putting the impulse value as an input, your y of t will be equal to h of t. This is the property. Y of t convoluted with delta of t is equals to y of t only. So write down the question. From the question it will be more clear. You need to calculate the impulse response for the following LTI system. Calculate impulse response for the following LTI system. So impulse response means they had given your x of t is delta t. X of t is your delta t. So first question is y of t, they had given x of t plus t naught plus x of t minus t naught. So how you will, means for impulse response y of t will be equal to h of t. Okay, y of t will be equal to h of t for impulse response. So h of t will be, and it's given x of t is equals to delta t input. So this will become delta t plus t naught, and this will become delta t minus t naught. Okay, this is your answer. Second question is y of t is equals to integration minus infinite to t x of tau into d tau. So for impulse response, x of t is equals to delta t only. So x of tau means delta tau. So what is the meaning? Minus infinite to t, x of tau means delta tau d tau, and the integration of a delta tau minus infinite to t will give you unit impulse function, unit step function. So what you are getting, y of t is equals to u of t, that will be equal to h of t. That will be equal to h of t. What about this? If you have y of t is equals to 1 by time period t minus t to t plus t x of tau d tau. So x of t is equals to delta t. Input is delta t. So how you can write this? 1 by t minus t to t plus t delta tau into d tau. So what result you will get? What result you will get? The integration of delta t is
u of
u of
t plus t minus u of
t minus t to t plus t. Right, put the limit 1 by t u of t plus t minus u of t minus t. Very simple. So how the figure will be look like? U of t plus t means it's starting from minus t, and u of t minus t means it's starting from this position. Both are getting subtracted. The magnitude is 1 by t only, the magnitude is 1 by t only. So if both will be subtracted, you will get one rectangle. From which range? Minus t to plus t and 1 by t. So this is your h of t. This is your y of t, which will be equal to h of t, because this is the impulse response. Understood, guys? Priyanka, understood? Or any issue up till here? If you have any doubt, you can ask. Any doubt if you have, you can ask till here. Priyanka, any doubt till here, up to here? Prasanna, any doubt up to here?
Clear, sir.
Clear. Okay. So it's clear, then it's fine. Okay. Write down the next topic. Output calculation of LTI system. Output calculation of LTI system. So how we calculate the output? So see, you are giving your x of t to any continuous time LTI system. Okay, this is your y of t, and what is the y of t value? Y of t is equals to, y of t will be x of t convolution with h of t, correct? Because y of s by x of s is equals to h of s, and if you want to write in the form of time domain, so y of t will be x of t convolution with h of t. And if you want to write the formula, how you will write? Minus infinite to infinite x of tau h of t minus tau into d tau, the formula of the convolution, correct? The formula of the convolution. And if it is in the form of a discrete x of n, that was the continuous system, and if it is a discrete time LTI system, so what you will get? Y of n, correct? And this is your h of n. So y of n will be, here in a time domain it is integration, but in the discrete domain we are writing summation, and the formula will be the same only. Minus infinite to infinite, write x of tau to means x of k, integer value, and h will be n minus k, same thing, n minus k. So this is nothing but this is your x of n convolution with h of n. Okay. So simple example, note a very simple example. You have unit impulse signal delta n. Okay, discrete, I am telling in the form of a discrete. So delta of n is equals to 1 at n is equals to 0, and 0 at n is not equal to 0. So what is the meaning? It will give you delta n value, you will get here 1 at 0, and rest of all the value will be 0 0 0 0. Okay, so second example, if you have x of n is equals to 5 delta n plus 3, what is the meaning? You are getting the value n plus 3. N plus 3 is equals to equate with 0, so where you will get at minus 3 the delta function will operate. So at minus 3 you will get what value? 5. 5, and rest all value will be 0. Right? Now if you have the equation like this, x of n is equals to 5 delta n plus 3 minus 3 delta n plus 2 plus 3 delta n plus 7 delta n minus 3. So what the figure will come? At minus 3 you will get, at minus 2 you will get, at 0 you will get, plus 3 you will get. So at minus 3 what value we are getting? 5.
5.
And at minus 2 what value is coming? Minus 3.
Minus 3.
And this will be 3 at 0.
Plus 3.
And here you will get 7.
7.
Right. Okay, this is your x of n.
Sir, in the previous question, in the second question, we have given the indication.
Yes?
Nothing.
Any doubt, Prasanna?
No, certainly.
Clear. Okay. So suppose if you have a figure, like what is the, how you will write? So suppose you have, anyone has given you some particular figure like this, x of n, right? So wait, just wait. Yeah. Yeah, just wait. Okay, so if anyone had given you a figure like this, so what will be the equation? You just tell me. Okay, so this value is minus 3, this value, this particular value is minus 2, this particular value is minus 1, this particular value is 0, this particular value is 1, and this particular value is 2, and this particular value is 3. Okay, so they had given like you this value is x of minus 3 minus 2, this value could be x of minus 1, this value could be x of minus 3, This value could be x of 1, x of 2, x of 3, like that. It's going, and this is x of 0. So how you will write in the form of your x of n? How you will write it? So some value is coming like this, plus, so this is your weighted value. X of minus 3 is happening at what position? Delta n plus 3.
N plus 3
Yeah.
plus x of minus 2.
X of minus 2 value,
And
delta n plus 2.
that of n plus 2.
Plus x of minus 1 value at delta n plus 1. Plus x of 0 at delta n. Plus x of 1 at delta n minus 1. Okay. And x of 2 delta n minus 2 is going like this. Right. It's going like this. So how can we write in the form of summation? How can we write in the form of summation? Summation k is equals to minus infinite to infinite, this x of n, x of k, delta n minus k. Put the value. The same equation can be represented like this. Correct? Put any value, means x of minus 3 you will put, then k will be minus will become plus. X of minus 2 value, so x of minus 2 will come. Then this k will become minus plus 2. So you will get the same equations. The value of a k is minus infinite. Understood? Understood or not? Just tell me. Priyanka, understood? Prasanna, understood or not?
Okay.
Priyanka, you understood? Give me the response, guys. If you will not give me the response,
Yes.
okay. So fine. Okay, so this was the concept of some LTI system. Now we'll further study, means like a convolution purpose. So convolution is used for calculation of a output of a LTI system. Why convolution we use? Okay, convolution purpose. So purpose of a convolution is what? Convolution is used for calculation of output of LTI system. Okay, so condition for LTI system to be static. Write it down. The second condition, okay, so this convolution is used in only LTI system. Okay, one property is also this. Now write it down. Condition for LTI system to be static. I told you the meaning of static. It will depend on present value, only present value. So y of t is equals to kx of t, and if you are taking y of t is equals to h of t, so your x of t you are assuming that is delta t. Okay, so h of t is coming k delta t. Okay, and if you finding the h of omega, it will come k. What is this? Okay, see, you are considering your y of t is equals to kx of t. Okay, you are considering that y of t is equals to kx of t. So y of s will be kx of s, and x of s will be x of s only. Divide both things, so you will get your transfer function y of s by x of s is equals to h of s, and what the value you are getting, k. So this is your, so h of omega you are getting k, right? Okay, so for a static LTI system, impulse response of the system should be impulse at origin, and the transfer function should be constant. So this transfer function means whenever you are getting the transfer function as a constant, that means the system is static. Remember this point. Whenever you are getting, means y of s by x of s is coming constant, that means your system is static. Okay, for a static LTI system, impulse response of system should be impulse at origin. Impulse at origin, no scaling, no shifting will come, and transfer function should be constant. Remember one. Okay, so for a static LTI system, impulse response of the system should impulse at origin. Okay, so suppose you are taking your y of t is equals to kx of t, and your, this is your input, and your x of t is equals to delta t. So if you want to find the impulse response, means if you convolute, so h of t will be y of t convoluted with x of t. So put the value h of t is equals to y of t is equals to k delta t, convolute with delta t. Right? So what value you will get? K value you will get only. Okay, convolution means you need to, so this delta t value, so you need to find the value at this particular delta. So delta t means this. So at 0 means you need to put the value of a t is equals to 0 here. K delta 0. So k delta 0 means k only, because this is delta t minus 0. So you need to put the value in this. So you are getting h of t is equals to k. So it is coming k only. Means at delta k is equals to, you are getting the impulse response. Basically you are getting the impulse response, k delta t. So I told you, use the property x of t convoluted with delta t, use that property, the result will be x of t only. Okay, so I am using that property only. So this is delta t, so the result will be k delta t only. That means at 0 I am getting the impulse response. So what is written? For a static LTI system, impulse response of the system should be impulse at origin. So impulse I am getting, one impulse, sudden impulse is coming at 0. So you can write it like this: in terms of h of t you will get k delta t, in terms of h of omega or h of s, h of omega right or h of s right, you will get k value. So you need to check the value whether it is static or not. So quickly check and tell me. First question is h of t, they had given 2 delta t minus 1. So whether it will be static or not. where this value will come at 1. So what is the statement? They had said that the static LTI system impulse response should be stable, should be impulse at origin. So whether we are getting at origin, no, we are getting at
No.
1. So this is not a static function, it is dynamic function. It is dynamic function. Correct? Or even if you want to find the Laplace transform, h of s will be 2 delta t minus 1. So t minus 1 is there, so e power minus s is coming. Okay, Laplace transform. So delta t minus a Laplace transform is e power minus a s. Delta t plus a Laplace transform is e power as. Okay, so this is the Laplace transform of delta t minus a. So what is the Laplace transform you are getting? 2 dot e power minus a. So whether this is the constant value? No, it is not the constant value. If the result was like that, only 2 simple or 8, 9, 10 simple, nothing is coming with this, then we can say that this is an static function. But we are not getting the constant value, so it is by checking with the Laplace transform also we are getting the dynamic value. Dynamic value. Correct? What about this? What about this particular equation? H of t is equals to u of t. Whether it will be impulse or dynamic. So if you will make the equation, means a graph, so the graph is like this. So whether you are getting an impulse? No, no impulse is there.
No, it's dynamic.
Dynamic. Okay, what about this third one? H of t is equals to e power minus 2t u of t. Impulse or dynamic? If you will make the graph of h of t, how the graph will be? It will be like declining. So whether you are getting an impulse? No impulse. Dynamic.
Dynamic.
You will, means static means you will only get the impulse value at 0. Then only the system will be impulse. Okay. Correct? Now the fourth question. Tell me about this. They had given h of s is equals to 2. Like that. It is impulse or dynamic? It is impulse or dynamic? Means static or dynamic? So constant value they had given. So this is directly you can say static. If h of s is given as a constant, and if they are giving like this 2 plus j also, it is static, because these are the constant value. What about this? If the transfer functions they had given like this, 1 divided by s plus 1, so this is constant? No, it is not constant. Dynamic. Constant means simple number. Simple number that will be in a Laplace domain, frequency domain. Okay. I told you about the low pass filter. Low pass filter is 1 plus SCR plus 1, or in terms of 1 plus S. I told you in this thing network. The if the equation, though this is the low pass filter only, and if you are having a h of s is equals to s minus 1 divided by s plus 1, so whether it is a dynamic, no constant value, so it is dynamic only.
Dynamic.
And this is the example of all pass filter. In all pass filter, whatever the terms you are getting upside, the means this is positive, this is negative, so positive means the reverse, real part opposite sign will come. Okay, so real part opposite sign is coming here. All pass filter. Or you can see, if you will draw the pole 0 diagram, so pole is coming where? Here, and 0 is coming where? Minus 1, 0. This is pole. So these are giving me a mirror image. means at particular distance -1 and 1. So from here to here the distance it should be same. From here to here distance should be same. And if a more pole will be there, so you will get a circle diagram. Okay, if here a pole is coming in the same opposite direction, 0 must become. If here pole is coming that same opposite direction, 0 must become come. Okay, so this kind of a structure will give you all pass filter. So by constructing this pole 0 diagram also you can say whether it is all pass filter or not. So what is the meaning of filters are dynamic? Note it down. Filters are a dynamic system. Filters are dynamic system because of because of their transfer function, because of their transfer function depends on frequency, depends on frequency. Actually my writing is very poor. Okay, depends on frequency. Okay, so yeah, so this was the concept of okay uh, static or dynamic in terms of LTI system. Okay, understood up to here, or is any doubt?
Yes, sir.
Okay, if you understood, then it's good. I hope you remember the causal and non-causal system. I hope you remember the causal or non-causal system. I taught you. So if you have a figure like this is my -1, this is x of t, and if it is passing from any system and I am getting y of t like this -3. So this is causal or non-causal system? This is causal or non-causal system? This is your output. This is your input. -1,
Non-causal, sir.
-1 to infinite input is there. And here it is -3. So -3 means it's depending on the future value.
Future values are
Non-causal. Because output starts before input. Means your input is -1 and the output is starting before the input, then the system will be non-causal. So because the output start before input, it should be non-causal system. Okay, so it should be a future giving input. Okay, what about this? Tell me. Question 2. If it is like this, so -1 to t, x of t, and this is your system, and you are getting the output like this. This is y of t, this is t, this is 2. So this is causal or non-causal system? So it's not depending on the
Causal.
future. Yeah, it's a causal system. Causal because output get after input. Okay, so it's not depending upon the future value. So I hope I had given you a particular example of a causal and non-causal, and I taught you causal and non-causal. So these things you should know very perfectly. Okay, basic signals, in the basic signals only. So this was the okay signal we discuss, mathematics equations we discuss, convolutions, basic system. Yeah. So what is the meaning of a causal? If output system is independent of the future value of system is called causal system, right? What is non-causal system? If the output of the system depends on the future value input at a time, then the system will be non-causal system. What is anti-causal system? A non-causal system in which output depends only on the future value. Okay, so every anti-causal system will be non-causal. Every anti-causal system is a non-causal, but vice versa is not true.
But vice versa is not true.
Yes. Now I hope you recall these things because I already shown you these things. Okay. So like that in the gate examination they will give you and they will ask you whether it is a causal system or non-causal system. Okay. In ES examinations also they do the same. What about this? Tell me this question number 3. You have an input that is delta t. It passes from LTI system and you are getting the output is h of t is equals to 0 for t lesser than 0. Okay. So this is what? This is the condition for causality of the LTI system. Means if you are providing the impulse response, means as an input if you are providing the impulse response and your output is 0 for t lesser than 0, then the system will be causal. Then the system will be causal. Okay. They had given they are asking. Okay, question 1, you are having a h of t and the graph is like this. So your h of t is 0 before t is lesser than 0. So what kind of a system is causal system? Directly write it. Okay, and if anyone is asking you, you need to find y of t, what you will do? Y of t is equals to x of t convolution with h of t, right? And x of t is this, and h of t, how can you write this h of t? U of t minus 1, correct? U of t minus 1. And since this was the delta function, so delta t convolution with u of t minus 1. U of t minus 1. Okay. Now just and you can do like this also, u of t minus 1 convoluted with delta t, and I told you the property, it will be the same, u of t minus 1 into delta t, means u of t minus 1 will come directly. You can write it like this. And even if you will go with the in the form of Laplace transform, so u of t minus 1 Laplace transform will be e power minus s divided by s, and this is multiplied with 1 only, and inverse of this will be u of t minus 1. Okay, I will tell you how this minus is coming. See, basic Laplace transform, I will tell you what is u of t, or better you can, okay, when the time will come, then I will teach you the Laplace transform. Okay. Now the second question, h of t, they had given e power minus 2 t plus 1 u of t. So what is the meaning of this? How can you write it? This is a causal system or non-causal system because you have a u of t, right? You have a u of t. Whatever the equations is this, e power minus 2t, see, these two particular equations are getting multiplied. E power minus 2 t plus 1 means what? So if t is equals to infinite, if t is equals to minus infinite, so if minus minus will become plus, so this value is coming like this, and it will be when t is equals to, when the value of a t is equals to minus 1, when the value of t is equals to minus 1 is this one, this is your minus 1, so this is 0, so 1 is coming. The value is 0, so some particular value is coming like this, and it will become 0 like this. So if the equation was given like this, then the graph is like this. So then your h of t before t is lesser than 0, you will not get 0, but it is multiplying with u of t. So if we will multiply this u of t, so this whole part will become 0, and you will get the circuit, the graph like this only. So that means t before 0 is 0. H of t is equals to 0 when t is lesser than 0. So this is your causal system. Directly you can say. Okay. What about this, guys? If the question is given h of t is equals to u of t plus 1 minus u of t minus 1. So whether it will be a causal system or not, u of t plus 1 means this. U of t minus 1 means this. Both are getting subtracted. So you are getting the signal like this. Minus 1 to plus 1.
Non-causal.
So it will be non-causal. Correct? So this is non-causal. Okay. Same one, another question. So this is your h of t. Okay. And your h of t value is e power minus 2 t plus 1 convoluted with u of t plus 2 convoluted with delta t minus 4. So what will be the answer? I told you x of t convolution with delta t will be x of t. Okay. Better to understand like this, x of t convoluted with delta t plus a, whole thing will be replaced here, x of t plus a, means in place of t it will be replaced. So guys, so this, the convolution of this will be u of t minus 4. In place of t, we will directly write t minus 4 plus 2. And the convolution is this done, e power minus 2 t plus 1. what you are getting? E power minus 2 t plus 1 convolution with u into t minus 2, correct? U into t minus 2. Okay, and x of t convolution with u of t, the property I told you, that is integration minus infinite to t into x of tau into d tau. So this is the properties of if the step function convolution is there. So here also the step function convolution is there. Step function convolution is there. So minus infinite to whatever the t present. So t is my t minus 2 and x of tau is e power minus 2 tau plus 1 into d tau. So when you will integrate this function, what the value you will get? Just do like this, minus infinite t minus 2 e power minus 2 tau into e power minus 2 into d tau. So this is the constant value. So e power minus 2 is the constant value, minus infinite to t minus 2 e power minus 2 tau into d tau. So the integration of e power minus x is equals to e power minus x only. E power minus 2 e power minus 2 tau. So minus 2 will come down, minus infinite to t minus 2, because e power minus x integration is e power minus x. E power minus ax integration is 1 by minus a e power minus ax. So that's why. So e power minus 2 by 2 minus, put the value. So you will get e power minus 2 into t minus 2 minus e power minus 2 into minus infinite. So this will give you so this is giving me some value like this. So minus e power infinite is coming. Okay, and you are getting a function, and this will be e power minus 2t plus 2, and here it is e power minus 2 by 2 negative sign. So if you solve this, so e power infinite minus e power minus 2t plus 2 e power minus 2 by 2. So put the value, means this is your h of t. So if you will put h of minus 1, h of minus 1 is this. If it is non-zero, then the system will be non-causal. E power infinite minus e power minus 4 plus 2. So e power minus 2 and e power minus 2 by 2. So this is infinite. Infinite minus anything will give you infinite only. Okay, so means the value from before 0, some value is coming. So that means this system is non-causal. Correct? This system will be non-causal. Understood, Prasanna? What I did it? This is the property. This is the property. So I'd applied the property. First property I'd applied here. U of t plus 2 into delta t minus 4. This whole term will be get into this. Convolution of this done. And the unit impulse property is this. This is the t function. So minus infinite to t x of tau into d tau. This is the property. So I'd applied that property. So t minus 2 is this, minus infinite to t minus 2 e power minus 2 t plus 2 d tau. Right, integrate this, and what I need to check that the value of a t before 0, it should not come any value, means you should get 0, but while I'm putting t is equals to minus 1, I'm getting some value. So that means it is non-causal system. Non-causal system. What about this? If I'll give you h of t is equals to u of minus t plus 5 minus u of minus t minus 1 convolution with delta t plus 2. Okay, yeah, this is the question. So associative properties means apply, uh, this will get multiply convolute here, also this will get convolute here. So we can write like this: u of minus t plus 5 convolution delta t plus 2 minus u of minus t minus 1 convolution with delta t plus 2. Apply the property. If you will apply the property, the value of a t will be replaced by t plus 2. So you will get u of minus t plus 2 plus 5 minus u of minus t plus 2 minus 1. Done. The convolution is done. So you are getting u of minus t plus 3. You are getting minus t minus 3. Correct? Minus t plus 2 will become minus 2 minus 2 minus 3. Okay. So if anyone is telling you what will be the graph of this, how you will draw? First draw u of t. Then shift it by minus 3 means plus 3 means it will be minus 3 na. So it will be minus 3. So this is u of t plus 3. Then you need to reverse this. U of minus t plus 3 will be like this, means it will start from 3. So this diagram done for this. What about this? U of minus t plus minus t minus 3. So u of t is this. U of t minus 3 is this. This is u of t minus 3. And u of minus t, if anyone say, is like this. So this is u of minus t minus 3. Okay. This value we are getting like this. Okay, let's check it. You have minus t plus 5. So you will put t plus 2. So minus t, so you are getting plus 3. Okay, correct. What about this? Minus t minus 1. Okay. So minus t plus 3 curve will get this like this also. Okay, correct. And correct only. Okay. So this was your minus 3. So this will become plus 3. This was your plus 3. So this will become minus 3. Yeah, minus 3 will come. Minus 3. If you will scale it. So this is my minus 3. So minus 3. This is my minus 3. And both are getting subtracted. So you are getting the curve like this. Minus 3 to plus 3. So this is non-causal. Correct? This is non-causal. Understood up to here? Or any doubt? This is the first class concept only. Priyanka understood or not? Prasanna understood here? These all are understood?
Yes, sir. Yeah.
Okay. So like that, we need to check the stability or instability of the LTI system. So how can we check the system is stable or not? How can we check the system is stable or not? Okay, guys. Okay, these things, stability and instability, we'll discuss. Not discuss means we have a half an hour to discuss. Okay, okay, we'll discuss it now only. So write down the next topic so that we can start the fourth chapter by tomorrow. So condition for LTI system to be stable. So for stability of a LTI system, impulse response should be absolutely integrable. Absolutely integrable means you are not getting any infinite value. Then it is called as a stable system. Stable system. So impulse response means you are making your input as a delta t. So that is minus infinite to infinite h of t mod value dt should be lesser than infinite. And this can be written as minus infinite to infinite y of t also dt lesser than, because at impulse response y of t is equals to h of t. So you need to check whether the system is stable or not. Okay, question. You need to check whether the system is LTI system is stable or not. So this is your one LTI system, minus 1 to 2. This value is 4. This is your h of t and this is t. So this is stable, because if you will find the integrations from minus 1 to 2 h of t into dt, you will get a finite value, because this is a triangle. So area you will get, right? So directly you can say this is a stable system. What about this? Question 2. If you have h of t is equals to e power minus 2t u of t. So what will the figure of this? It's like this. Okay. So whether it will be stable or unstable, guys, whether it will be stable or unstable. So from 0 to infinite e power minus 2t you are getting means dt. So if you will integrate this, you will get the finite value. So stable only. And by the graph also you are seeing that this area can be calculated. And what about this? H of t is equals to e power 2t u of t. E power 2t means at infinite you will get the infinite value. Stable or unstable? Prasanna, it will be stable or unstable? So see, area you can't find. Infinite area will come. No finite area is coming. Unstable. Correct? Is this clear? Is this clear, guys?
Yeah, sure.
Okay. So see, question number 4. E power minus 3j t u of t. This will be stable or unstable? if you will find the magnitude, what you will get? E power minus 3jt magnitude is 1 only. Okay, so you are getting u of t, 1 u of t, and 1 u of t is like this, means it's going like this. So this area we cannot find, so this is unstable. Unstable. Okay. And fifth, if they had given a h of s is equals to 1 divided by s square plus 1. So what is the Laplace transform, inverse Laplace transform? H of t is equals to sin t u of t. So the curve is like this. Sin t u of t means it's like this. So this is also unstable. Sin t u of t is unstable. Okay. But if you will see in the form of poles and zero, they are say marginally stable. In control system, we'll discuss what is the meaning of marginally stable. Okay, sin t u of t. Okay, now write it down some formula. I will give you Laplace transform, because Laplace transform are using very much. Okay, so a divided by s square plus omega square. A divided by s square plus omega square is the Laplace transform of sin at u of t. Okay. Second, omega divided by s square plus omega square is the Laplace transform of cos at u of t. Okay. Laplace transform of u of t is 1 by s. Laplace transform of u of t minus a is e power minus as divided by s. Okay, from delay this function is coming. Laplace transform of a delta t is 1. If Laplace transform of a delta t minus a will be there, e power minus as will become. Or you can say if delta t plus a is there, e power as will come. What is the Laplace transform of e power minus at u of t? Then 1 by s plus a will come. 8. E power at plus at u of t, opposite sign, 1 upon s minus a will come. If 9, if e power minus at sin t is given, then you will have 1 by s plus a the whole square plus 1 ka whole square. Or suppose it is at. Okay, e power minus at sin bt. So 1 by s plus a the whole square plus omega of the whole square. Here b will come. E power minus bt cos at, if it is like that, so omega s plus b the whole square plus omega the whole square. So you need to know this particular formula. and the Laplace transform of, yeah, you just learn this concept. So these things you should remember. Okay. Okay, while we'll do the Laplace transform in maths, we'll derive this how these things is coming. Okay, but for now you just remember these things. So you are getting your function is h of s, example 7, 6, right? 6, example 6. So h of s is equals to 1 by s. So 1 by s means h of t, inverse Laplace transform of 1 by s will be u of t. Okay, we wrote the formula. So what is the meaning of a u of t? It's like this. And if in terms of a poles 0, where will be the 0 will lie? Poles will lie at origin. So if poles are at the origin, the system will be marginally stable. We say this is marginally stable. But in signal system, we'll say the marginally stable system is unstable only. But in control system, it will be marginally stable. So these two conditions are satisfied for this. And if you have h of t is equals to 1, h of t is equals to, yeah, r of t. So r of t means the signal is like this. So if you, the area will be infinite. So it is an unbounded amplitude signal, we can say. So unstable, bounded input bounded output criteria यहाँ पे फेल हो गया. So note it down. One property. No property. Just note it down. All marginally stable system are unstable according to Bibo criteria, bounded input bounded output criteria. Okay. Okay, so this was the condition. So Laplace transform, you need to revise the Laplace transform, and this means you have to understand, you have to learn these things. Okay, so make a table in your notebook and revise these things, because Laplace transform, by using the Laplace transform only you can get in a gate 7-8 marks if you know the Laplace transform. So now we will see the standard differential equation of LTI system. Write down the heading. Standard differential equation for equation for LTI system. LTI system. So guys, what is the standard differential equation? An is the coefficient d power n y of t divided by dt to power n plus an minus 1 coefficient d to power n minus 1 y of t divided by d to the power n minus 1. It's going like this, and you will reach up to a naught, where you will get y of t only. and you can write like this also. It will be equal to bm d to the power m x of t divided by d to the power m plus bm minus 1 d power m minus 1 x of t divided by d t to the power m minus 1. It's going like this, plus b naught x of t. So these are equal. Okay, so this is the standard differential equation. So important point, write it down, some important point. Okay, condition for linearity. What is the condition for linearity? Initial, we already discussed, initial condition of system should be 0 linearity. And condition for time invariant, LTI means linear time invariant. So condition for time invariant. What is the condition for time invariant? Coefficient of an minus 1, a naught, bn minus 1 should be constant. So this coefficient should be constant. So coefficient for an minus 1 like that, a naught, bm minus 1 like that, b naught will be constant. So they are directly giving you a question from this. Means they will ask you with check the linear time invariant and linearity. So what you will do? So this is your question: d square y of t divided by dt square plus 2 dy of t by dt plus y of t, they are given like this, x of t. So this is linear or non-linear? I say about this equation is linear or non-linear? This is LTI system na. So you are getting, see, there is a no initial condition, and all the coefficients are constant only. So here coefficients are 1, here coefficients are 2, here 1, in this part coefficient are 1 only. Okay, so this is LTI system. Directly we can say linear time invariant system, right? We can say na LTI system. What about the question number 2? If you are having dy of t by dt the whole square plus 2 dy of t by dt plus y of t is equals to x of t. So due to the whole square, it's coming non-linear. Okay, due to the whole square, so it will be non-linear, but it is time invariant because the coefficients are constant. So this making non-linearity. Example 3, d square y of t divided by dt square plus 2t dy of t divided by dt plus y of t is equals to x of t. Whether this is linear or non-linear. So this equation is linear, but it is time variant. Why time variant? Because we are not getting the constant equation. Okay. So condition means see how you will check the system is linear or non-linear. I already told you. Like you have uh, yeah, you will substitute like in this what we are doing. You are putting x of t equation as x1 of t. Okay, you are putting y of t equation as y1 of t. Differential equation 1. Then you are putting x of t is equals to x2 of t. Y of t is equals to y2 of t in differential equation 2. Okay. Then you are substituting x of t is equals to x1 of t plus x2 of t. Okay. Third equation. And you are doing equation 1 plus equation 2. And these equations are not coming to equation 3. That means non-linear. Additivity principle we check. Okay. Additivity principle. So if you will put in this form, you will get here, what you will get here, dy1 by dt the whole square. d1 by dy1 by dt the whole square 2 dy1 by dt plus y1 of t is equals to x1 of t. Here what you will get, dy2 of dt the whole square plus 2 dy2 of dt plus y2 of t is equals to x2 of t. Now if you are putting the equation x1 plus xt, x1 plus xt, so what you will get, x1 plus xt, you will get only dy by dt the whole square. You will not get the sufficient answer. Means this will come y1 plus y2 the whole square. So y1 plus y2 the whole square will give you y1 square plus y2 square plus 2y1 y2. Okay. Anything square means like see, you have a y of t, you are getting the input, you are applying the input x of t and you are getting output as a x of t the whole square. Okay, so these things happening. So here what dy by dt the whole square was there. So in the square term, see x1 of t if you will apply, you will get x1 of t the whole square. x2 of t you will apply, you will get x2 of t the whole square. When you will apply x1 of t plus x2 of t, you will get x1 of t plus x2 of t the whole square. When you will add this here, you are getting x1 of t the whole square plus x2 of t the whole square. Okay, and here what you are getting, x1 of is x1 of t the whole square plus x2 of t the whole square plus 2x1 of t plus into x2 of t. Extra term is coming and these twos are not equal. That's why this is non-linear. So in a simple way, I can say like this. Okay. So that's why when you are getting any number of squares and all, overall, you will not get the non-linearity. Means non-linear system will come. Now if you will apply these things, the same things, the same logic if you will apply in this, you will get the linear function here. But the coefficients are not constant. It is the multiple of a t. So you will get time variant system. Time variant system. Understood? Guys, is this clear? Is this clear? Is this clear? Priyanka, is this clear? Prasanna, is this clear? Okay. So what the things we had discussed today, I will give you a quick review summary. because means I need to make a summary video for 2-3 minutes, so that even the videos will be missed, or in the last moment of the examinations, by watching the summary you will recall the concept. Okay, so today we had started from this things was the yesterday topic, is the previous class topic. Mapping already, yeah, stable done. So linear time invariant system. Okay guys, so see the summary, quick summary. So linear time system is applicable only for transfer function. Transfer function h of s. H of s is nothing but Laplace transform of output divided by input. Okay. So we can represent it in the form of an impulse response. So when the impulse response means when your input is your delta t, that is your impulse response, you will always get h of t, and h of t will be equal to y of t. Okay, this can also be represented in the block diagram. The LTI system means your zero input response, ZIR response is zero, means your initial conditions are zero. Okay, and the transfer function is Laplace transform by output by input. So ZIR I already discussed. ZSR we know that is the forced response, that is the natural response. And definition of the transfer function I told you, y of s by x of s. Impulse response, you understood that input is x of t will be delta t. So by putting the input as a delta t, you will directly get h of t. Okay, so this is the concept of finding the LTI response. Y of t is equals to x of t plus, so you need to put x of t is delta t. So in terms of everything I put in a delta form, so we get the result. So this was the property, means like that properties we had applied, and we got the results. Okay, so like that we had solved this overall questions. And yeah, so x of n is equals to, this is the discrete, in a discrete domain we represent like in the form of summation, but in the time domain we write in the form of integrations. And the convolutions formula we already discussed in the past. So this whole things can be represented, this all are the discrete functions, and this whole things can be represented like this number, and the summation form is like this. So convolution is only used for what? Calculation of the output LTI system, we discussed this. Okay, so for the system will be static. When the system will be static, when you are getting h of s is equals to k, means h of omega is equals to k, and the impulse function at 0 point you will only get. Okay, at origin you will get. So by this way we can say that which is static and which is dynamic. Okay, and for causal and non-causal system, when your h of t function is 0 at t lesser than 0, the system will be causal. When you are getting the h of t function at t lesser than 0, then the system will be anti-causal. The same things we had applied here. Okay, and calculation for the system of a stable or unstable, if you are getting the h of t finite area, then the system will be stable. If you are getting the infinite area, then the system will be unstable. So for this you need to apply the integration. Okay, so these things we did. If the imaginary term is coming, e power minus 3jt, you need to take the mod value. Here if you will take the mod value, you will get u of t. So u of t means you are getting the one from the infinite at infinite point. So this is marginally a stable system, but in the bounded input bounded output criteria, marginally a stable system is also unstable. Okay, same things we had applied, and this is the formula of the Laplace transform we discussed. Okay, just go through this Laplace transform formula. And yeah, this was the okay. And the next slide if we'll discuss, so this is the standard differential equation of the LTI system. Okay, these are equated with this. Okay, so important for linearity, initial conditions should be 0, and for time invariant, if your coefficient is constant. So by this we solve this particular 1 2 3 questions. So in this question, this is LTI system. Why so? Because it's forming the basic law of this equation. Okay, this is non-linear system because dy by dt the whole square, and if you will check in the form of this, apply the additivity principle, you will get non-linearity. If non-linearity is coming, So this is not LTI system. So it is non-linear time invariant system. For this system we cannot find the transfer function. Similarly for this, this is the linear system. Even if you will apply for this linear additivity principle, you will get linear principle, but time variant because of this t. So this was the lecture of today. We'll meet tomorrow. Okay guys. So I hope these things you understood. Okay, we'll meet tomorrow. Thank you very much.
Thank you, sir.